Okay viewers, well I decided to check my Rewound MOT, just unwound it because I realised when I wound it the winding is all crisscross most of the time and parts of the way. You can see the wires started to melt together. It really wasn't very efficient the way I wound this, but here's what I worked out. 32 turns equaled 7 volts AC with this gauge wire. So this is probably something you find in a caravan like this. This is just a main earthing cable using something small like this. But yeah, so 32 turns of this equals 17 volts on the output and about 180 amps I worked out. I got a bit bored. I wanted to try something. I found some 4 gauge car audio amplifier cable to rewind in that transformer instead. And look what I've done with a screwdriver here. It's enough. It's a 1.7 volts. Haven't worked out the amp, so it's enough to make this red hot and very easy to bend. Like wet spaghetti. That is nice. And also I don't have a proper set of brass clamps for that cable. I just use battery terminals. One was a good quality brass one, one was a cheap one. While I was arcing that screwdriver and melting it, this cheap battery terminal, well you get the idea, it kind of melted. Either it's made of lead or some cheap aluminium or alloy material. It's enough amps to melt that battery terminal. That is a lot of amps. The brass one got warm, it's still warm to the touch. This primary barely got even, I got lukewarm, that's about it. This core was still staying cold and these wires are still staying cold. So the primary wasn't even feeling that most of the time. This was barely doing any work. Pins barely got warm, so I was probably pulling about an amp from the mains, if that. But yeah, when you're winding these, the neater job you do, the better. Don't crisscross and yeah, try to make sure it's a continuous and neat wind. Don't cross and get them up the other way and tangle them, like get one there and tangle it, because it makes the transformer less efficient. And also when you're rewinding one of these, just do your tight, rewind it, feed in and feed out, feed in and feed out. Don't cut the welds and lift the laminations apart because the laminations are separately insulated from the factory, and they weld as less as possible. And that's because it's eddy currents which build up between these laminations. And if you just weld this back together yourself and you do a bad job and you short too much of it out, the laminations will be all conductive through all the way, and the eddy currents will tend to overload the primary. So what I just did, hacksawed one side of the secondary when it was still original. Took it off and just hammer and chisel, back my way out, just came straight out. But yeah, just try and leave it as original as you can. That way the transformer has its original efficiency and won't overheat so easily. I'm going to change this for another one of these brass ones. I'm going to show you just how much amps this thing can push out. It's quite amazing. That's all I got. Haven't got any longer cable than this. That's all I could find. Otherwise I would have done another one. Maybe 2 turns, so about 3 or 4 volts, so probably maybe 1000 amps total. I haven't worked out the amp rating of this, as I said, so it's probably about 900 at least, as it is now. That's a pretty big cable. So yeah, let's get this thing repaired. Okay viewers, something I forgot to mention before. Brass has a lower resistance, so we tend to not complain, so to speak. So that's pretty dirty connection for such low voltage. I need a good pure connection for a low voltage application like this, but I got this. I'm just going to try and burn this and melt this stainless steel kitchen knife blade. It lasted 30 years and the damn handle finally snapped off of it. It was a good knife for a cheapie, so let's end it. Must have a, depending on the resistance of the metal you use, but this is starting to give in. It's pure stainless steel and she's starting to show signs of giving up. Yeah, connection broke loose. It's there, I need a better connection. Yeah, it's melting the damn lead. Yeah, don't need something like that bad connection. And none one of these types of battery terminals. Brasses to get this is to go with these. Yeah, you got the blades melted to the bloody thing now. Viewers, got a bit interrupted, but yeah, let's continue burning some stuff. Let's just get there. Yeah, only 1 volt, but it's a lot of amps. Yeah, it's burning my wire. Alright. Try this motor shaft. Oh yeah, it's getting hot now. Warning smoke. Yeah, I don't know how much amps this is, but it's definitely more than 100 amps. I'd say it's at least 400 or 500 by the way, how hot quickly that got hot. I don't know. It's not bad for a 500 watt transformer. Matters a bit in my variac. Shaft them. Oh yeah. Liquefy the motor shaft. That's not going to work again. I blew it up completely anyway. It's not ever going to work again. Oh yeah. That's a lot of amps. Oh no, so it's probably like shorting a car battery across something. That's a lot of amps there. Oh, let's try this hard drive motor I popped. Oh, hot metal spat on me. Melted it. Power's off. Check for heat. Barely even warm. Oh, it was. I'll see what else I can put. Milo can lid. This will burn good. Must forget the rules of magnetism. That kind of scared me. I really want to wreck that new battery clamp, but it's kind of fun doing this. There you go, the battery terminal's melting. I don't know how much amps this is, it's a lot. That's a lot of amps. What else can I burn? Remember the hard drive spindle. Battery terminal eats away. Okay, viewers, well, that's enough for tonight. Battery clamp gets eating away. There's bits and pieces of it dripping there. I'm going to do some modifications to this and add some good clamps to it, so yeah. Try and find some heavier cable too. I don't think that I'm going to have much luck though. But anyway, Thanks for watching.